Hey there. Today we'll be doing another Leetcode problem, that is unique paths 2. So now let's get on to the question, what it states. Uh, a best way to do this question would be, I'll say, to actually check out my video on unique paths 1. It will give you more clarity. But if you have just come to this video, so still let's get on to this question. A robot is located at the top left corner of a M cross N grid marked start in the diagram below. The robot can move either down or right at any point in time. The robot is trying to reach the bottom right of the corner. Just like the question in Unique Paths 1, we had a robot and we needed to go at the bottom right position. But here, the only change in the problem is that we have some obstacles in our path, and the obstacles are denoted as 1 and the space is denoted as 0. So now let's clearly understand how this question actually works. So I'll just draw this same grid like how it's represented here and get this over with. So I have something like this, and I say the 1th index is representing that I cannot go there, right? Now what do I have? I have a robot here. Okay, this is the starting point and this is the ending point. Okay, I'm writing E here, which means this is the ending point. Let's get this bigger. Okay, so we have the starting point here, we have the ending point here. What are the possible paths that we can take to reach the end? One of your way could be to start right from here and go till here. Another way could be to reach this way, right? So these are the some of the possible ways in which you can reach it, right? So I'll just remove this also, and I'll just remove this part also, this E. And now let's say if I have another obstacle right here, so what all paths can I take? I can either take a down or I can take a right. So what is the path? So this is the only path that I can take to reach this down position, since I cannot move diagonally, right? If I could have moved diagonally, then I could have gone here, then I could have gone here, but this is not permitted as per the question, so I will not do that. So the only possible path is this. So this is the brief overview of the question, how it is. So now let's get on to the part of how we are actually going to solve this question. So it is pretty obvious from the question, since we can see the constraints are so low and we need obviously to try all the paths so as to check in how many ways we can go till the end. We will be using the question here. So now let's get on with the question. I'll just draw the example once again. So 10, okay, so I'll just let me just draw this. So this is where my robot stands. Okay, this is the face of the robot, and I'll just draw the grid. 1, 2, and this is how it goes, and this is my end. So I'll just draw this end with black. This is where I need to reach, and there is an obstacle in between. So this green part is an obstacle, right? And I can all together take these white spaces as my free paths or my free roads to go on. So what can I do? So what is this position? This is 0 0, right? So I'll say from 0 0, what can I do? I'll just write the indexes as well. So this is 0, this is 0, this is 1, this is 2, this is 1 as well, and this is 2 right here. So what can we see here? We start from 0 obviously. Now what are the possible paths that I can take next? I can either take a right or I can take a down. Okay, so I'll first say I'll take a down, and when I say down, I'll go on to this index, right? 1 0, that is this position. After that, I'll say I'll again go down. Fine. So this is the next position that we go on to next. Now I can say after I've reached here, I can say I will take a right as per the question, and I'll go here. And what is the index that is here? That is nothing but 2 comma 1. After that, I'll reach the end, that is nothing but 2 comma 2, which is my required destination. But after that, can I go any further? Obviously not, right? We cannot go any further since that is out of bounds. So there's nothing right here. So we cannot go there. And now what we will do, we'll just return 1 since we actually reached the path. So now what this recursion will return is, it will return 1 to it. Now this in turn will return 1, this in turn will return 1, and it will return finally here what? Nothing but the path that we could take, that is 1. Okay, so now what we have, the other option, as we could have taken a right at the beginning. Okay, so what is the other option? That is, I could have taken something as 0 comma 1. So this is a possible path. Again, I could have taken a right. That is, again it is going to take 0 comma 2. Again I can take what? Now I'll take a down. Fine. So when I take a down, this is what I reach 2. That is 1 comma 2. And at the end of the day, again if I take a down, I'll see I reach the end. Then again it is 2 comma 2. And when I reach 2 comma 2, what happens? I'll say we return 1, right? Like we did here. So at the end of the day, we return 1, 1, 1. And this is how it goes. So I made two recursion calls saying you go and take a left, or sorry, you go or take a right, or you go take a down. So these are the possible combinations that you will get. And there are more recursion calls, but I have not written everything. Like here, we got something as 0 1, right? And after that I took a 0 2. I could have also said that I will go down. I could have said, right, that I will go down, that is 1 comma 1. But is it possible to go down, since there is an obstacle, right, which I mentioned at the beginning? So I cannot go there, so I'll simply return a 0. So from here it would have returned 0. So that is why we 0 is not equivalent to anything, right? When we add 0 to my answer, does it make any sense, or does it give me a better answer? Obviously not, since we are just concerned about the actual paths which I can take to reach this position, that is the end index, that is 2 comma 2, or any m minus 1 n minus 1 according to the question. So now let's get on to the code. Since you have understood how to do this and the intuition as well, so the code is pretty simple here. We just do something like, it is the exact same code as unique paths 1 question. If you have not watched it, I've already uploaded a video, you could check it out. But here is another concern that we have to check, is the base case. And also there is another case, that is, if my ending index, that is here, if there is an obstacle, can I reach? Obviously not, we cannot reach, right? If the doors are closed or if there is blocked road, how can I reach there? Obviously not. And if the starting index itself is blocked, can I reach? Obviously not. Again I cannot reach there, since I'm starting from the 0 0 comma. So these are the two cases that I've written. If the first and the last guy itself is blocked, that is 1, I cannot go there and simply return 0. So now I call this recursion, and this code is exactly similar to the code that I had written in Unique Paths 1. So again, I'm telling you, please do refer to it. You will understand why I have done this. And this is the same left and right call that we were doing. And at last, we returned L plus R, whatever we could get. And if you have not understood, I'll just go through this code once again, why we are doing this. So what this first step is doing is saying that, let me get to the code, that if I and j exceeds the bound. What do we mean by exceeds the bound? Let's say I'm here, right? I'm here right now. The robot is here. Now, if the robot says I'll go further right, can it go further right? Obviously not. It is out of bound. What will I do? I'll just simply return 0. So this is what I've done here. So this is taking care of that case. Now, in this case, why have I returned 1? Since if I reach this index, that is m minus 1 and n minus 1, or the last box of the grid or the matrix, what will I say? I'll return 1, right? Since I reached 2 comma 2, I returned 1. So this is what I've written here, that is return 1 comma 1. And if, and this is the memorization step, that dp of ij is not equals to minus 1, return this. This is pretty similar. And if I've given here another condition that here I had 0 comma 1, right? I was at this position, the robot was at this position. Let me just take another pen. The robot is here right now, and if I want to take a down, can I take a down? No, since there is an obstacle right here, so the robot cannot go at this position. What will it do? It will simply return a 0, which I had previously written here. That is return a 0. So this is what I've done here. If there is a position 1, if there is a 1 in the grid, return 0. Otherwise, at the end of the day, return L plus R, that is the number of calls that I was doing. So from here I got something that is 1, and from here I got something that is 1. So I'll simply return summation of these things or these recursion calls. And at the end of the day, just return dp of I of j, which is also storing the answer. And if you run this, it will run perfectly fine. And yeah, this gets accepted. I've already submitted this code also right here. So yeah, if you did understand this solution, please do like and subscribe. And yeah, that's it for this video. Thank you for watching.